everyone, I'm going to talk about 146 LRU cache. The question is design the data structure that follow the constraints of the least recently used LRU cache and implement the LRU cache class. Okay, so LRU cache, it means initialize the LRU cache with positive size capacity. And we have the function which is called get, right? Get key, it means the return the value of the key if the key exists, otherwise return -1. And the third one is put function. We have the key input and also value, update the value of the key if the key exists, otherwise add the key value pair to the cache. If the numbers of key exceeds the capacity from these operations, evict the least recently used key. So the functions get and put must each run in O1 time average time complexity. Okay, so let's write something here. We can write the list node plus right. So for here, I want to write some for this list node. Is the solution of this use the double linked list, which means we have the head and also have the tail to maintain the recently, right? So this is one the recently, and this is for this side is like I need to old one. Now I need to create the list node priv, and also int key, int value. This key, this value. Okay, then I need the list node head and also list node tail. And also I need a map to store the key value pairs, like integer list node. Okay, so this one is the and then this one, wait a second, is map to store the scene, and also I need the int per size, int capacity. Yep. Now we're going to initialize those of things. You create a new this tail, create a new list node. -1, -1. And also this map is equal to the new hash map. Curve size is 0. And this capacity and this capacity equal to this. Okay, so now we get this key, so we can check the map first. This one, if map contains key, right? If not contains, so I don't need to. If the map contains the key, then I need to return, which means not exist, to -1. Otherwise, which means the map contains key. Then we can do something here. So map contains the key, so we need to update it. So update the node. This node is equal to cur get key and then return the node value. Now, how could we update the private update the node? So how could we update this node? There are two steps. The first step need to remove it. Remove the node, and then move to the head. Private void remove this thing. Then we should do some stuff like remove, right? So node preview nest should move to the node nest, and node nest preview should point it, nest preview should point it to the node preview. Connected. But for now, right, you can see just remove that. It's fine. Even the current node is connected to the thing, is fine. Now we move to the head now. Move to head. Okay, so move to the head. So how could we move to the head? Move to the head is the head one, right? So we have to connect it first. Let the node connect it first. So node previous should connect it to the equal to the head, and the node nest should equal to the head nest. So connect them first, then break it the head and the head nest. So head nest previous connected to the node, and node and head nest equal to the head nest equal to the node. Yeah, then connect it. Okay, so what about the put? Put is quite different. So first thing we definitely need to check the map. If the map contains the key, this means map not contains. If map contains the key, then we can do something like if the map contains the key, we can do something. Update that. Is the node map get the key and node value equal to this value. And also update the node. And for here, if not contained, so we also need to check the capacity. List the node, new node, key value. If the curve size smaller than capacity, so which means we can move in. And curve size plus move to head array. New node and also update the map. Otherwise, which means we need to remove at least. I will remove old node. How we're gonna do is the node last is equal to the tail pref. Remove the last. Map get the last key, delete. Okay, this one is and then curve size minus. Now we move out this one, then we can add a new one. So repeating this one. Let's see. I'll update the curve. VA value. Okay, wait a second, this one didn't connect and had an S equal to the tail. And node value list the node map get. this value, no this value, so cannot find. What's going on? Okay. Okay, so for the delete, remove. Yeah. And for the time complexity is the no while loop, so just to create it. So average is O1 time for every functions. And for the space, we create a map, right? So for here, we take O1 time. So space average is O1 time, and space is O1. We create the table. Yeah. Get is O1, and put is also O1. Yeah, thank you.